Welcome to another lecture of Academia Libera Mentis, and today, on the morning whereby the tragic news is that another war has broken out in the Middle East, it's very important to have a good news lecture. Things that are going well with mankind as a whole. Now, in previous lectures, we already learned that there are now more humans than ever before. We're above 8 billion, it now seems. Life expectancy has risen at least 100% since the early 1800s, and we're close to a top there. But today I want to talk about other good news. Right? It's already good news that we are with more than ever before, and we're living longer than ever before. What other good news is there that we can really be proud of? We can say, okay, things are looking good for humanity as a whole. The first thing I want to show you is just how much extra nature there is in this world. Right? So this data, that's the next one. The first graph I want to show you is something that tells you about how cheap food has become over time. This comes from the Food and Agricultural Organization, which has tracked world food prices since the early 60s. And it basically tracks how much people need to expend for their food in this world. So it's sort of an average price of food. And this is the real price of food in the sense that it takes out inflation. Right? So it basically says that the equivalent of $1 in 1961 buys the same amount of food, roughly speaking, as it did in 2019. And now we're maybe only 18% above the cost of 1961. Indeed, if you look at the real food price in 2024, or in May 2025, it is almost at exactly the same level as it was in about 1973. So really, though there's been a dip and ups and downs, the real food price in this world has not risen for 60 years. Right? At the same time, people have gotten much richer. So since the 60s up till now, people have got about 2.5 times more richer on average in this world. So whilst the incomes are 2.5 times higher, the cost of food has remained the same. So basically, we now need far less of our total budget to feed ourselves in this world. That is fantastic news. Right? That is great news. It basically means that food has stopped being a huge problem for the world as a whole. Despite the fact that we are with more people, we found it actually easier to feed ourselves. Now, why does that come? Right? What are the two big drivers of this ability to feed ourselves in the world? Well, one is that agriculture has become more productive. So for the same bit of land, we are now far more productive than we used to be. How more productive? Well, we have new crops, right? New crops that are better resistant against heat, against drought, against pests, right? And also, of course, agricultural methods, fertilizers, machinery, crop cycles. We've basically worked out much more than we did in previous centuries how to get a lot of food out of a smaller bit of land. And we're still getting better and better at this, maybe 1% better every year, which is a lot if you think of that over a time period of 50 years. In fact, we've become so good at producing food that we now, in 2024, need less land to feed the whole of humanity than we did in the 60s, despite the fact that we're over 2 times more people. So we've gotten more than twice as much out of our agricultural land. That is how good we've got at it. And one of the estimates is that we now need 18 million square kilometers less land than we used to feed ourselves. 18 million square kilometers. To put that in perspective, the whole of Australia is about 7 million kilometers. Russia, 11.5 million square kilometers. So we've sort of gained the equivalent of that amount of land which we no longer need to feed ourselves. That is fantastic news. And that is also what explains what happens during food crises. So at the start of the Ukraine war and at the end, of course, of the disastrous lockdowns in the early 2020s, food prices went up. Right? There was a a crisis in transportation, lots of normal ways of doing agriculture were disrupted. And so food prices in the world rose, and that, of course, caused many problems. Lots of poor people couldn't feed themselves well, and you had riots in many parts of the world. What then happens, of course, is that more of that land which wasn't needed to feed us was taken into cultivation. So in places like Central Asia, in places like Brazil, in places like India and China and Europe and North America, just more land got used again. Food prices are up, and so farmers think, I'm going to have some extra fields. And that increased food production in the world as a whole, and then depressed food prices, as we could see. So from the peak in 2022, we've reduced world food prices again by 20%. And since we've had this estimated 18 million square kilometers left, we can do this even if humanity doubles in population size, which is not expected. Food prices should be expected to remain stable and hence fairly low. Now that's great news. We as humanity are basically in no danger of huge famines, right? We are in no danger of sort of having to have wars over scarce land or scarce ability to feed ourselves. We are basically no longer in danger of starving ourselves. That is great news. That is fantastic news. And that is also independent of anywhere in the world. There are now so many areas in this world which are more productive than they used to be. That also includes Europe, China, and India, that even if in one part of the world major wars would break out, the rest of the world just produces more. And people are not used to thinking this way, but since most people are in cities, this is already their reality. The vast majority of us humans don't make our own food. We live in cities and it's brought to us. We buy it at supermarkets. We don't actually need our own fields to make it. And so that principle also extends at the world level. There are whole countries like Singapore, Vatican City, which make no food themselves at all, not in a significant amount, which is brought in by other places which have more than enough food. So this also tells you about the wonder, as it were, of the international economic system, that food is very cheap to produce and also very cheap to transport now. Great news, fantastic news. In centuries gone by, or even in the 1940s, it was predicted, there's going to be hundreds of millions of deaths due to famines. It's no longer a realistic possibility. Famines now do exist, and they're local, but they're usually because of wars, because there's some enemy which is trying to deliberately starve a population and prevent food from getting there. It's no longer a matter of money or even being too poor. It's usually now a matter of warfare. That, of course, does keep on going. Now, the second bit of good news, which is related to the first bit, is just how much more fertile the world has become. And by fertile, I mean more leaf coverage. So what this shows you is a mean leaf area index. Now, for people who don't know what that means, it's basically how much leaf you can find on every square meter in this earth. And you can ask yourself, well, how would you know how much leaves there are? Well, this is one of the great things of satellite data, right? Satellite data can look down on the earth and essentially see how green is it, and can map every little area of this world, and that has been tracked since the early 1980s, right up to the modern day. And you can work out, okay, the more green I see, the more leaf there must be. And then you need to line that up a little bit. You need to look at particular areas and then go into fields, okay, how much green means how much leaf. But they've worked out that the average square meter in the world approximately has 4 square meter of leaf in there. So there's more leaf square meter than there is actually square meter because, well, if you go to a forest, there are many layers of leaves. There are also many grasses on there. So you actually have more leaf coverage even than you have square meters. So the average is about 4, and this has increased by about 1.5% every year since the early 1980s. So what this tells you is the trend in the growing season, mean leaf area, from 2000 to 2018. So there's more relatively recent data, right? It takes a while to sort of put all this together. And it shows you that hence in the areas like China, India, Europe over there, but also North America, you see that for those areas, largely it's a green thing. Now, a green in this area means that there's been a positive increase over time. If you see red, then that in those areas you'd have had a decrease in those 20 years. And you can hence see that for the vast majority of the Earth, vast amount of coverage, leaf area coverage has gone up, right? And has gone up quite a lot. To underscore that, this is another map which is based on satellite data, so it's effectively all NASA type data, and it's on their various websites, as you can see at the bottom. This again tells you the change in the leaf area, but now from a longer period, 1982 to 2015, so about 35 years. And it tells you that over 50% for the darkest green areas relative to 1982. So that means that more than 50% increase. Now, where do you see more than 50% increase the most? In India, in China, in Europe, North America, which is where lots of people live. Over half of humanity lives there. So where over half of humanity lives, where there's most agricultural need, where food is the most important, just the leaf area has gone up by more than 50%. Right? Wonderful news. It basically means more nature. And this is a trend which has continued. Right? Now, if you ask yourself, why this fantastic news, right? How come that the earth has become so much more fertile? Because, of course, nearly everything else eats of leaves, right? If you think of animals, insects, but even things like, well, not mosses, but yeasts, mushrooms, all kinds of other organisms, they nearly all basically feed off leaves, trees, and plants. So the basis of everything else in nature has grown an awful amount. Now, why? There is a major reason for this. And the major reason is CO2 emissions. Right? CO2 emissions have been predicted for a long time to be good for agricultural yields, and here is the evidence of it. Now, where do CO2 emissions come from? They come from our fossil fuel use. So every time we burn coal, burn oil, or burn gas, what we're effectively doing is we're burning the previous plant life of the last 200 million years, which has been buried in the earth for millions of years, and it is now once again in the atmosphere and feeding the plants around the world. And the plants around the world are sucking it up, and they're growing faster than for a long, long time beforehand. And you can here hence see who has been the beneficiary of that, particularly the highly populated areas of this world. That's amazing news, right? And it's also a trend line that is continuing as, of course, we are now emitting more CO2 out of its geological tombs than ever before. And so in a way, almost this good news is accelerating and shows no real sign of decelerating. So nature as a whole is fine. Right? People who say, oh, there's less nature now. Well, no, there's far more leaves and everything that eats of it, hence will also be more of. So you now and then get these scares, bees are dying out, this and that, but it's not true. Right? By and large, if you look carefully, it's the opposite. There's just more of nature. Right? Now, this doesn't mean that there are no species threatened with extinction. It doesn't mean there are no local problems. But nature as a whole, on a worldwide level, is doing great. Right? Nothing to worry about there at the aggregate. And nothing we can really do to even threaten that good news. Let me then give you another piece of good news. Right? So humanity is fine in terms of its ability to feed itself. Nature as a whole, and hence the ecosystems on which we depend, are doing great. Okay, we're looking good on that. How about our ability to sort of use energy in this world, right? We all hear, the fossil fuels are going to run out, this is going to be disastrous. Well, how about other forms of energy, and particularly the things on which we depend most, which is hence the forms of production for which we need a lot of energy. And I'm going to pick out one of those, which is desalinated water, right? People say to me, look, we're going to run out of water. The rivers are going to be used up. We're going to be thirsty in our cities. Nobody is going to be able to bring us water. Well, the big element into that is, can we convert some of the oceans into drinking water, right? Because, of course, most of us live on the coastline. That is true for everywhere on this map. The most populated cities are usually pretty close to the coast. So if we can make drinkable water out of ocean water via desalination, then we're going to be fine. We're not going to go too thirsty. So this tells you a graph, and this goes from the desal data. So you can look that up. This was quoted in the Financial Times, and hence in mainstream Western media. Over time, what the cost of desalinated water is. And let's take you through this graph. On the left-hand side in 2000, you see the price in dollars per cubic meters. Now, a cubic meter of water is 1,000 liters. So for 1,000 liters, if you go to the supermarket, you'd have to pay hundreds of dollars even for sort of the cheapest water, right? But this tells you that, okay, in bulk, desalinated water in 2000 would on average, and each of the dots here is a particular desalination plant, so it tells you how expensive it is for particular plants in particular areas of this world, that on average in 2000 you had to pay over $1 for 1,000 liters of desalinated water. Now that's of course not necessary for your average drinking in a household, but it's necessary if you use a toilet, if you use showers, and for agriculture, right? Then for agriculture, $1 for 1,000 liters is actually pretty expensive. Well, what's happened with that? It's basically halved over time. So the latest data that we have here, the most recent desalination plants, you actually see that the average is below $0.50 per 1,000 liters of desalinated water. So we can now desalinate for maybe 40 cents for 1,000 liter. That is great news for households, right? The average household uses a couple of 100 liters of water every day, which, if you hence sort of multiply by that, is maybe 10 to 20 cents in terms of what it would cost us in order to desalinate it. Well, that's bearable, right? That's bearable. So that also means that for the long-term future, all these cities with tens of millions of people in it or millions of people in it, we're not going to die of thirst. We're just going to desalinate water from the ocean. We can pump it up. Solar has become a lot cheaper as well. Energy production has become a lot cheaper. And we'll basically create our own drinking water. So people who say to me, look, the rivers are going to be dry, it's going to be terrible for the cities, we're not going to have anything to drink. It's not true. It's not true, right? We just make our own drinkable water. And hence, in that sense, if you look at the things that we humans rely upon most, food, nature, drinkable water, the news is great. Now, if we look ahead at the future, this is what some scientists have been projecting. Again, this is on one of these NASA-related websites, and so you can look up who's been predicting this, but this is what they predict is going to happen with nature in the next 60 to 80 years. So this is again the mean leaf area index, but now 2080 to 2100, and the darkest green is areas predicted to have more than 100% increase in these coming 60 to 80 years in terms of their leaf area index. So that's a doubling, right? And where do you see a doubling is expected? Well, in large parts of India, parts of China, parts of Africa and Central Asia and North America. They're the main beneficiaries from the expected further increase, of course, of CO2 in the air. And again, this is where hundreds of millions of people live in India. Fantastic news, right? You see Central Asia, it could be the breadbasket of the world. There's huge areas there, which are hence extremely fertile and which are predicted to become more fertile. The same goes, of course, for large areas in Canada and the United States, parts of South America and Australia. So all the green areas are those who are predicted to win, basically, of the burning of fossil fuels that we're going to have the next 50 to 100 years. So this again tells you, okay, we're going to be fine in terms of food, we're going to be fine in terms of nature for the world and humanity as a whole. That's a fantastic predicted outcome for the coming 60 to 80 years. Then finally, I want to present you a graph that tells you this is not just true of the last 50 years, not just true of the last 60 years, but also our incomes have increased last year. So this is the latest data that there is on GDP, and GDP is an indicator of the average incomes of people in different countries. It's roughly the value of the goods and services that they produce. And this map tells you about the increase in 1 year, namely last year, in 2024. So this comes from the International Monetary Fund, the data that they've collected from the individual countries. And the darkest green countries here saw an increase of over 5.9, so over 6% for their population as a whole. You see some areas in red, which have hence decreased their average incomes, but those are very small relative to the places which have seen increases in their GDP. Only Argentina, which is there at the bottom of South America, saw a decrease, and you see some decreases there, which I believe is Sudan. And these, of course, are war-torn or highly politically unstable places. But again, you see in the most populous places of this world, which is China, India, Southeast Asia, you actually see large increases in GDP between 3 and even above 6%. If you then look at the areas which are growing a little bit, so from minus 0.2 to 2.9% plus, which is the light green, that's most of Europe, that's North America, that's also parts of the Middle East. It's still growth, but much less spectacular than the darker green areas. And so even last year, humankind was getting richer, nature was improving, the desalination is getting cheaper and cheaper, and hence, if you look at humanity from a long-run perspective, we're doing great. Right? Our ecosystems are doing great. This doesn't mean there's nothing to worry about. Doesn't mean that there's no death and destruction and misery on large scales in all kinds of areas of the world. That is tragic. And this morning again, there was more tragedy for us to mourn as humankind. But looking at us from a whole species, whole Earth perspective, there's only one conclusion to be had. Times are great. Thank you very much.